Record. Well, now, so I was explaining a broadcast domain. So I was saying for this PC that I had drawn there to send to get these guys, there was a server here. This server's MAC address, it will send an ARP request, and ARP request is a broadcast. You see, we've skipped ahead of ourselves because we didn't follow this topic 11. I think we were supposed to talk about ARP somewhere, topic no, 6, 7 or something. But here's the thing. So when it sends out that ARP request, this switch will flood it. Flooding means it will send it out all the incoming ports, all the outgoing ports except the incoming ports. So when it goes here, it is a broadcast. But routers never ever forward broadcast packets. That is important to note that routers never ever forward broadcast packets. So what the router will do, it will look at the source MAC address. It will see that it is all F. A broadcast MAC address will have a destination MAC address of all F like that. So what it will do, it will take that frame na itoe hii MAC address ya all F. It will remove it and put its own MAC address, put the router's MAC address there, and then once imeweka MAC address yake, then it will forward it to the server. And that is why we say that anytime a frame goes through a hop, the MAC address will change. So once imeweka MAC address yake hapo, when the server responds, so the destination MAC address from the server will be the router's MAC address. Now, when the router receives that frame, it will put its own MAC address now as the source MAC address at that frame. Then the destination MAC address itakuwa near that PC over there, and then it will forward it. We'll see this one again in simulation in a short while. So hopefully we will be fast enough and see some practical today. But so that is why we're saying in a network, in an IP network, routers, every router interface is a single broadcast address. So if this router has another interface here connected to another network, another one connected here to another network, another one, and another one connects to the internet, then we will say that this router has how many broadcast domains? 1, 2, 3, 4. So each of its interface is a single broadcast domain. Now that is for routers. For switches, each port on a switch, like this one, is a single collision domain. Every port on a switch that connects to an end host is a single broadcast domain. I mean, is a single collision domain. Okay. So then there's problems with large broadcasts. Now, the issue with the large networks is this, that look at this example given here. Let me just try and make this one better a bit. Okay, let's see this. Okay, I didn't want that. Okay, so let me just, okay, let's see this. Okay, here. So you see, look at this case. So that this LAN here, this LAN here has how many users? 400 users. So if we have Otieno here using a PC, and then is connected to this switch, and then he sends out a broadcast packet. That packet will be flooded to all these 400 users. Now, you look at a scenario where each of these 400 users, each of them send out broadcast packets. Those will be so many packets in this network eating up the bandwidth. And when we have so many broadcast packets eating up, because the issue with the broadcast packets is that most of them will be dropped because it is just a packet that goes to everybody. And so when it goes to a destination whose destination address is not what is specified in the packet, then that particular that particular destination will just discard it. So you will have so many broadcast packets eating up the bandwidth and getting dropped. So to make sure that the experience is better, then you want to break a broadcast domain into smaller domains. And you see in this case here, now this same network is broken down into two domains, each with 200 users. So it means again, if you have our guy here sending out a broadcast packet, if this guy here sends out a broadcast packet, now that broadcast packet will only go to 200 people who are in this LAN here, not to the 400 of them like here. It will only go to this 200 here. If someone else on this side also, if they send out a broadcast packet, it will be confined to only those that are within this LAN. And so that is the reason why you will want to break down large broadcast domains to avoid what we call broadcast storms, where you have so many broadcast packets in the network eating up the bandwidth and affecting user experience and causing unnecessary delay. Okay. So reasons for segmenting a network. Why would you want to segment a network? These are just some of the reasons here. Subnetting reduces the overall network traffic and improves network performance. It can be used to implement security policies between subnets because, for example, if you look at this one here, this network here, you don't want administration traffic interacting maybe with the student traffic and the people in accounting and human resource. You want every department to have its own segregated network. That traffic in the administration is confined within that particular department. But of course, again, for management purposes, you will look at VLANs at some point, and why we'll want to do inter-VLAN communication so that if you are admin, you can still manage the people who use accounting network or human resource network here. So, but for now, those are some of the reasons. Security, and another thing is that subnetting reduces the number of devices affected by abnormal broadcast traffic. Subnets are used for a variety of reasons, including, so you can subnet your network by location. You can say the people in the first floor will remain two upper, their networks become confined within first floor, or second floor, third floor, or you can do according to this one by department. Or you can also do subnetting by network device type. For example, all end hosts are on a particular subnet. All layer 3 devices, I mean, all servers are on a particular subnet. And then also all printers are on a different subnet. So those are some of the ways in which you can subnet your network. So to make a decision, that will depend with your requirement. So subnetting an IP network. So I think we've talked about this one largely. So what we've talked about, I will not take time to explain again. I think we've talked about how to convert these ones, how they come about. And this is still explaining where we are getting how these slashes, how you write them in dotted decimal, and the borrowed network bits. You see this guy says up to this is network bits. Then there's also the borrowing of host bits to make them network bits. Of course, this material you have again, if you want to go through it again and again, you can also do that. I think there's something particular I'm looking for, and when I get there, I'll use it as an example. Again, this is subnetting, and subnetting is still the same, whether you have a /16, a /12, it doesn't matter. Those procedures are the same, and I want to use a /16 in the example that I'm looking for, so that we see something here. Okay, yeah, look at this here, that we want to get this. We want to create 100 subnets with a /16 prefix. So consider a large enterprise that requires at least 100 subnets and has chosen the private address range of 172.16.0.0/16. So this is the network address that they want. But you see here, they want to have at least 100 subnets. Now, with this one, with 172, I think I'll just do these explanations here. It will be enough. 172.16.0.0 slash 24 slash 16, I mean. So this is just one network. This is one large network. Now, we are saying from this one large network, we want to have at least 100 subnets. We're just doing what we did yesterday. But now this one is a slash 16. So what you say, you just write out the slash 16 in binary. Slash 16 in decimal is 255.255.0.0. We all know where that one comes from. This is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And if you write it in dotted decimal, that is what we have. So we are saying, remember our requirement is we want 100 subnets from this. Subnets. So we start asking, what happens if we borrow 2 bits, 1 bit here? If we borrow 1 bit, that will be 2 raised to power 1, which will give us how many? 2 subnets, which is not enough. Subnets. That is not enough. What if we say we borrow 2 bits, 2 becomes 2 raised to power 2. That one will give us 4, which is not enough. If we borrow 3, that will be 2 raised to power 3, which gives us, I think, 8, which is still not enough. Then 2 raised to power 4. This one is 16 or something. Then 2 raised to power 5, which should give us, I think, 32. Still not enough. Then 2 raised to power, if we say 2 raised to power 6, this one gives us, 6 here. What is wrong with this? Power 6. This one gives us, I think, 64. Not enough. Then we say 2 raised to power 7. This one will give us 128. So now, this will be more than what we asked for, but at least it will take care of our requirements. So we can't go with 6 bits. So we'll borrow 7 bits. I hope up to that point we are all together. Now, we have now established that we need to borrow 7 host bits and make them to be network bits in order to have at least 100 subnets. So what do? You just say 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That is what we had. Then we add 7 more. 1, 2, 3, 4, 5, 6, 7, 8. Then 1, 2, 3, 4, 5, 6, 7, 8. So our new slash we will have now, this is 255.255.252. Is that true? Not 25. This is 255 minus 1, 254. Dot what? Dot 0. So our new subnet mask will be this, which in slash notation, this becomes a slash what? A slash that is 16, 17, 18, 19, 20, 21, 20, 16, 17, 18, 19, 20, 21, 22, 23. This one is a slash 23. This is now what will give us at least 100 subnets. So it's just what we did yesterday. I'm not going to now start looking at the number of hosts per subnet. I'm not going to go into that, but you appreciate that it doesn't matter whether it is a class C, you can still do the divisions, the maths here and get your requirements and meet your requirements. And so that is that. And I hope that that's clear. And I can clear this and go to the next slide. If you need to ask, you can always ask. Then this other one, look at this. Another example here that will help us explain that create 1,000 subnets with a /8 that consider a small ISP that requires 1,000 subnets for its clients using this network address here, a /8 network. So what does that mean? We need again to do the same thing. Let me just again do it here so that you also see that it's no different. So here we need 1000. So first of all, our address is 10.0.0.0/8. 0/8. So we need 1000 subnets. So we ask ourselves, how many will we borrow? Remember, if we write /8 in binary, that is in dotted decimal is 255.0.0.0. In binary, it is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now, if you write it in dotted decimal and in binary, this is what we get. Now, we ask, how many bits can we borrow to get 1000 subnets? Na I think tulikuwa tumesha borrow 7 na tulisema 2 raised to power 7 will give us 128, which is not anywhere near 1000. We continue. 2 raised to power 8 will give us 256. Still not enough. 2 raised to power 9 will give us 512. 512, which is still not enough. 2 raised to power 10 will give us 1024. Now that one meets our requirement that if we borrow 10 host bits, we will be able to create at least 1000 subnets. So then you come here and say we want to borrow 10 bits. We know from here to here, these ones are 8, 9, 10. So in the third octet, we borrow 2 more bits. So what will that one give us in binary? It will be 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. If you write this one in dotted decimal, it be 255.255.192.0. So this will become our new subnet mask. And this one is a slash, that is 16, 17, 18, a /18. This is what will give us at least 1000 subnets. So our new network, the first network address will be 10.0.0.0/18. And then, of course, you can do the math, get the broadcast and the rest. And so you can subnet, whether it is a class A, class B, class C, it doesn't matter. You can always subnet it to meet those requirements. Okay. I hope that is also clear there. Let's see here. Subnet meet requirements. Okay. Let me see this. Subnet private versus public IP address that enterprise will have given. Okay, I'll skip that. Don't see anything there. Minimize unused. Unused. Okay, let's see this. This is 4025. This is a good example of VLSM. So before we go to VLSM, I wanted to give an example, just one last example that relates to what we've been doing. I was saying that the other thing you will say, let me just now having demonstrated that, let's say here we want just that network, but we are saying we have 45 users. I'm at 25. Let's go with 45. And this is now /24. Just let's make it a smaller network. And we're saying we have 4 departments, and each department has 45 users. So what is the thinking process here? Now you say here that, remember, we need to have at least 4 departments, the 4 departments and at least 45 users. So how many host bits will give us at least 45 IP addresses? So we say, what is 2 raised to power 1 minus 2? That will give you 0. So that is if we only remain with 1 host bits. If we remain with only this one, it will not be enough. So what if we remain with the 2 host bits? So if we remain with the 2, such that we have 2 raised to power 2, and we must subtract 2. Subtract 2, that will give us 2 addresses. Still not enough for 45 users. The next one, if we have 3 host bits, what happens? It means that this is going to be 2 raised to power 3 minus 2. That should be to the that should be 6, which is still not enough for our 45. That is not enough. So we borrow another bit. We remain with another bit. We make sure we have that bit also as host bit and see if it will take care of our requirement. So that becomes 2 raised to power 4 minus 2. Now, 2 times 2 is 2 times 2, 4. Is it 16? Is it 14? I hope so. Okay. That is still not enough. We need another host bit here. And so we say we have those host bits, and those are 5 host bits. So 2 raised to power 5 minus 2 minus 2. That should give us, I think, 30. Which is still not enough for 45 users. That is not enough. So we go to the next one, which is 2 raised to power 6 minus 2. 2 raised to power 6 minus 2. Is it 62? I think it should be 62. Okay, 62. If it is not correct, you let me know. But that will give us 62 addresses, which is more than enough of what we need. And just to be sure, we can also ask ourselves, now that we are going to borrow these 3 bits and make them network bits, will they be enough to create at least four networks? We can just check that out and say, what is 2 raised to power 3? And this one gives us 2 times 2, that one is 8. So we will have 8 subnets, which is even way, way more than our 4 departments we have here. So now here is the thinking process that we need to have at least 5 host bits in order to make sure that each of our subnet itakuwa na at least 45 users. Actually, the exact number is 62. So with that now, that's how you think about it. So nani ako na swali mpaka hapa? Any question up to that point? Anyone with any question?
Yes, Apollo, as you are concluding somewhere there, you've said that we need 5 host bits to ensure that there are at least 45 users, but then 5 gets us to that.
Peter, I lost you.
I am lost at the point in which you are concluding this computation, saying that we need at least 5 host bits for the 45 users when we say 2 raised to power 5 minus 2 gets us 30 and not closer to the 45. I thought it could be the six host bits. I don't know.
Yeah, if I say that was wrong, but this is the correct answer. The last one is our answer, that we need to borrow at least 5. We need to have, what did I say? Okay, let me just, not 5, 6 actually. This should be the 6th one. That was an oversight. It should be, we need to have at least 6 host bits, as we can see here, at least 6 of them in order to have a minimum of 45 users per subnet. So yeah, that is what you are saying is the correct thing, that we should have at least 6. So that one leaves us with just 2. So this is 2 raised to power 2, which is actually now 4. Which is still also meets our requirement up here. Okay. I hope, Peter, that one now is clear.
Yes, thank you.
Okay. Now, before that was that is now subnetting a network that has uniform requirement. So where we're assuming that all the departments are the same. And if they are all the same, That is the approach. So number two, quickly, I want to repeat some of the things that we already covered. I will just go straight now to VLSM. VLSM is still the same thing. The only difference is now let's say we have Nairobi, Kisumu. I can let me just open Packet Tracer. Why am I? Let me see if I can do this one over here. But Packet Tracer's font is way too small. I just don't like it. But I can quickly drop a router here and then drop four switches. Switch 1, switch 2, switch 3, switch 4. And call this one maybe Nairobi. Call this switch here Kisumu. This is Nakuru. And then this is Eldoret. So this is the thing. Here in Nairobi, say we have 110 users. Kisumu, Kisumu here, I just want to put these numbers so that we easily see it. Kisumu here, that is the number of users I'm adding there, has maybe say 45 users.
Excuse me.
Yes, yes.
Can you share your other screen, please?
Oh, okay. Okay. Uh-huh. Okay, let me just share the entire screen. Okay. Able to see now my packet tracer?
Yes, we can.
Okay. So I'm saying that we have this router one here for now. So we have four branches. We have Nairobi, which has 110 users. This number here is just to just keep this simple. It has 110 users. Then Kisumu here has 45 users. Then say Nakuru here, we have maybe say 29 users. And then maybe we say this is Eldoret. The newest kid on the block maybe has just 8 users or something like that. So if you look at this and we have this one address, the address that we have is, now let me use, we've used, let's say 172.160.100.0/24. So we need to divide this address to make sure that it takes care of all these branches here. Well, I can even connect the branches. Just take this. Okay, I have only 4 interfaces. I mean 3. So I'm going to miss one, but I'm going to try and add a serial interface. I can add a serial interface here. Switch it off. This should be serial, add it here. And we use one of those connections will be a serial connection. Okay. So this here, a serial connection should be this. So serial 00. Oh, okay. This other guy also needs a serial interface. Now, let me just see if I can do this. Okay, I'll connect this one, but I just that connection there. We needed to have more than those number of interfaces we have there. But there is the case now, before we will sort that on Badai. So we now need to do subnetting here. But make sure that 110 users, let me just put this one here so that you see the number of users. 110, 45, and 29 and 8. So the approach here now, what you do, you start by subnetting the largest subnet. Yeah. Start by subnetting the largest subnet. So that is what you start with. And in this case, the largest subnet is Nairobi. So we ask, how many host bits? No. How many, host bits do we need? Do we? need to have 110 user addresses, host addresses. So that's how we start. And so you say, if we say 2 raised to power 2, that is not enough because that is just 4 minus what? 4 minus 2 will leave us with just 2 addresses, which is not enough. Now, I don't want to go through each of them. I'll skip. I'll go, what is 2 raised to power 5? 2 raised to power 5 will give us, I think, a total of 30 if we subtract 2. Then 2 raised to power 6. This is the one that gives us 62. Still not enough. Then what is 2 raised to power 7? What is 2 raised to power 7? Minus 2. Mwenye ameshafanya hii hesabu, 2 raised to power 7 minus 2. 126. I hope that is correct. Now, so we know that if we only have 6 host bits, is not enough for people in Nairobi. Some people will miss network connection. So we can't go with this. So we have to go with this option here, where we are borrowing, where we are remaining, we're not borrowing, but we are remaining with at least 7 host bits. That means we are borrowing 1 bit and making it to be a network bit. So what does that mean? It means that we have 172.168.100.0/24. And we are saying now we want to, if you write this in binary, the /24 in binary, you need 255.255 in as a decimal, .255.0. In binary, it is 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. And we are saying that we need to make sure that the host bits are at least 7 of them. 7, as you can see here. So,
So,
yes.
just a concern, but at we need at least 2 bits for the network. I mean, are we supposed to give 2 bits to the network since we have 4 branches?
Okay, now that one now, when we talk about fixed length subnet mask is when we are concerned with that. But when we're doing VLSM, the case is now a bit different when it is VLSM. Because after subnetting the first subnet, we will subnet the second subnet again.
Okay.
Okay, so this is now where VLSM becomes very different with the FLSM. So now we're saying that these 7 bits must remain as host bits. So we'll then borrow this 1 bit here and make it to be a network bit. So our new subnet mask will be 1, 2, 3, 4, 5, 6, 7, 8. Okay. Can you guys hear me?
Yes.
Okay. Now, what was I trying to do over here? Let me just why do we have all this? Let me delete that. And okay, I don't know. This is a repetition here. Fine. Let's say, so I was saying that we need to make sure 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. And then we have 1, 1, 2, 3, 4, 5, 6, 7. So now our new slash, this one is the same as /20. What is slash is this? /25. Is that correct? So therefore, ladies and gentlemen, the gentlemen that are here, this one will be the network address for Nairobi will be 192 dot 168 dot 10, dot 100 dot 0, but now /25. And now from there, we work out to get our broadcast address. And remember we said to get a broadcast address, just take your network address and convert all the host bits to all ones. So if we write out we're going to focus on the last octet here, this one here. So for the network, it is 1, 2, 3, 4, 5, 6, 7, 8. For the what? What is this? For the network, for the mask, it
We're
is
using 192.
1. Yes. Somebody was saying something? Okay. So now,
Is it 192 or 172?
okay, poleni sana. I don't know why I'm so used with one. It should be 172 dot 16.100.0. Thank you for that. That is what we are using. So it will be 172.16.100.0/25. And remember, now we don't touch, let me just get this. Like we said, we follow that rule. We don't touch this we're trying to get the broadcast address, so we don't touch these ones. So all you need to do now is convert the remaining, these are the ones here, to all zero, because it is broadcast to all ones. Easy upper. And if you do the maths, I know it will give you 127. I can see it. So I'll not do the maths here because we all know how to do that. So what I'll do, I'll say now, the broadcast address then is the broadcast address for this one here. Broadcast address is equals to 172.168.100.127/25. Now, our broadcast address is ready. So we are done with Nairobi. We go to the next largest, which is Kisumu, and we ask, what is the IP address? What is the network address for Kisumu? So to get the network address for Kisumu, you take the broadcast address of the previous network, in this case, Nairobi, and add 1 to it. So we say it is now 172.168.100.127 plus 1 is 128 /? So what slash will ensure that we have 45 users, a minimum of 45 users. So again, I'll not do I'll say 2 raised to power 5. If you say 2 raised to power 5, what is 2 raised to power 5? But first of all, remember initially here we have 25 before we even now ask the question, what should we have there? For now, it is 25. So 2 raised to power 5 minus 2, that should give us 30. Is not enough for 45 users. So you ask, what is 2 raised to power? Where is this one? Raised to power 6. This will give us, I think, 62. And 62 is enough for Kisumu users. So if it is 62, that means we have 6 host bits. So if we write that one out, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. Remember for /26, 25, tulikuwa tumefika hapo. Then 1, 2, 3, 4, 5, 6, 7. So before we subnet, this is what we have as our slash. But we are saying for us to have 45 users, we only need 6 host bits, just 6, not 7. So it will mean we'll turn this on to be a 1. And so we'll have borrowed 2 host bits. That's one more host bit to make ikakuwa network bit. And so this now will become a /26. And so now here, our network address for Kisumu will now become a /26 here. And now with that, we need to get a broadcast address, and then from the broadcast address, get the network address of the net subnet. So to get the broadcast, we follow our general rule of thumb, broadcast address write out your network address in binary. I'll just focus again on the last octet peke yake, which is this part peke yake. And that in binary should be 1, then 1, 2, 3, 4, 5, 6, 7. And then you write the /26. The last octet of this is in binary, which will be 1, 1. Because we borrowed, we have 2 bits there, then 1, 2, 3, 4, 5, 6. Now, network portion is this portion here that we aren't going to touch. The network portion is these 2 bits here. So we will not touch these 2 bits, these 2. But then the remainder, these remaining bits here, we convert them to all ones to get the broadcast. So if you convert those one to all ones, if you do that maths, haraka haraka, who anana amefanya. So if you convert that one to all ones, I mean not there, hapa chini, itatupea. Of course, this one now if you convert it, itakuwa 1, 0, 1, 2, 3, 4, 5, 6, which if we write that broadcast, itakuwa 172.16.100. What? Anybody mwenye ameshafanya hiyo? Minus 64. 191. That will be the broadcast, and it is /26. Now you see it is not uniform like with the FLSM. Now we go now to the next one, which is this Nakuru. Now with Nakuru, we want to say what is the network address for Nakuru. The network address for Nakuru, you take the broadcast address for Kisumu and you add 1, which is 172.100.191. That is the broadcast for Kisumu. But you add 1, it becomes 192 / we still retain /26 for now, but then there's a question mark there. What / should it be? Because we are carrying that / from the previous network, but is it the correct one? The answer is no. We need to find out if it is the correct one. And to find out, we ask ourselves, how many host bits do we need to make sure we have a minimum of 29 users? So if we say 2 raised to power 5, this one is 30. This one will be 32 minus 2 will give us 30. Is that true? I hope I'm not too fast. Ama naenda mbio sana.
On my end, I'm following.
You're following?
Yes.
Yeah, then that's very good. Nikienda mbio sana, you just let me know. Well, now we're saying that if you take 2 raised to power 5 minus 2 will give us 30. And that is exactly what we need. Now, remember hapa tuko na /26. And we are asking if it is the correct thing for us. Because if you write that in binary, it is 1, 2, 3, 4, 5, 6. I mean, not 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, 8. So our current /, which is /26, looks like that in binary. But we are saying we don't need all these 6 host bits. We only need 5 of them, and these 5 host bits will be enough to take care of these 29 users here. So what are we going to do? Tutasema hii pia sasa inakuwa 1. This one also becomes a 1. And so our new /, if we write this one in dotted decimal, inakuwa 255.255.255 dot what? 192 plus 32. 192 plus 32 gives us 224. So that is our new /, which is, this is the same as /24, 25, 26, 27. This is /27. And so our network address for Nakuru becomes /27. And from there, we need now to get the broadcast address for that network. Again, following that very rule, you just write out, because we know these ones will remain the same, the first 3 octets. You just write out the 4th octet in binary. And if you write out the 4th octet in binary, it will give us 1, 1, then 1, 2, 3, 4, 5, 6. And then you write out also this 4th octet here subnet. By the way, this is called the subnet mask, this one here. You'll also hear it being called the network mask, this /27. This is the subnet mask. It is the network mask. So when I'm saying subnet mask, that is what I'm saying. So because I know these ones will remain as they are, the first 3 octets, so I'm not focusing on them because they just remain like that. Our interest is the 4th octet here. So with the 4th octet, we now put it down here and say 1, 2, 3, 4, 5, 6, 7, 8. Now you don't touch the network portion. The network portion, remember, is these 3 here. These 3 are network portion. So in other words, I'm saying we don't touch these 3 here. These 3. Then to get the broadcast, all you need to do, once you identify the network portion, convert all the remaining bits to all ones to get to a broadcast. Convert them to all ones. So if you convert that to all ones, then what do you get? You get this. You then get, let me just put it here, what we will get now. After converting what is this? The network bits, the host bits to all ones, you get 1, 1, 0, then 1, 1, 2, 3, 4. This is what you get. And so if you write that in binary, should give us, that should be 255 minus 32. Yeah, 255 minus 32, which is 223. 223. So our broadcast for, which is this? This is Nakuru. Our broadcast for Nakuru will be 172.168.100.223/27. And we have worked out the network for Nakuru. From here is easy. Once you have the broadcast, it's easy to know the total number of. By the way, let's just work out for Nakuru here. Total host addresses is total host IP addresses. Utapewa na the number of host bits, which is 2 raised to power 5 minus 2. The answer is 30. And we did that even across the other ones. It's only that I didn't mention that this is the total number of host addresses. Yeah. Now we work out the last one, which now is I want to put this one up a candle to have some space to work out the one for Eldoret. Now for Eldoret, it's very easy. We only have 8 users. And so we take our broadcast address from Nakuru. Our broadcast address was 172.16.100.22. Was it 2 to 3? Yes, and we add 1 to it. It becomes 2 to 4. And this one is /27. And then now you ask, how many host bits do we need in order to make sure that we have at least 8 users, a minimum of 8? So if we do 2 raised to power 4, that is gives us 2 times 2, gives us 4, 4 times 2, gives us 8, this one gives us 14. Okay, let's see. What is 2 raised to power 3? 2 times 2, 4. 4 times 2. That one is 8, right? Sometimes even simple maths can refuse to, but that should be 8. So we only need 3 host bits in order to make sure we have a minimum of 8. A minimum of 8. So that means that if we write out our /27 in binary, should be 1, 2, 3, 4, 5, 6. I mean, okay, 7, 8.
Excuse me.
Yes, Dominic?
in this case, why haven't we subtracted to get 6?
Thank you. We said the maths can refuse to maths. That is not sufficient. That is correct, Dominic. So we can't say we need 2 bits. So we need 4. So we need, so it means that 2 raised to power 4. Yeah, at least you guys should be attentive like that. So 2 raised to power 4. That is 16 minus 2 to give us 14, which will meet our requirement. So it means that we will need at least 4 host bits. So that is if we now write out this one in dot decimal, we will have that. Then 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That is 24, 25, 26, 27. And then 3, 1, 2, 3, 4, 5. So this is our slash notation from Nakuru. Now we need to make sure we only have 4 bits here. We don't need this 5 of them. So it means this, we convert this other bit here, this one to be also a 1. Now, if we convert that to be a 1, it means that this one is no longer 27, but it is slash 28. And so that now is our network address. So once we have our network address, it's easy to get the broadcast. And we just use the same steps we have used to get our broadcast address. So what do? Let's again focus on the 4th octet because that is where the change will happen. So to write that one out in dotted decimal, I mean in binary, not binary 2 to 4, that should be 1, 1, 1, 192. Okay, if you 192 plus 32, 2 to 4. So there should be those 3 bits. Then 1, 2, 3, 4, 5. Alafu, we write slash 28 also in what? In binary. 28, the last octet. I'm focusing on this last octet here. Because the rest we know will remain the same. So we will have that there. And then we map out the network portion. The network portion is 4 bits up. We don't touch those ones. Then what do we do from there? Just convert these ones to all ones to get the broadcast. So if you convert that one to all ones, then what we get is this. Let me just put this one here. If you convert those ones into pair, it will give us 1, 1, 1, 0, 1, 2, 3, 4. Actually, that should be 255 minus 16. Minus 16, which gives us 239. And so with that, our broadcast address will be 172.168.100.239 but slash 28. That is how you work out VLSM. Subnetting to meet network requirements that has different requirements in terms of host IP addresses. Up to that point, any question that anyone wants me to clarify? Okay, maybe we needed to do...
Yes, excuse me.
Yes, Dominic?
I've been trying to follow, but when it gets to somewhere, you are see the long one where the 000. When
Dominic, you are breaking. I don't know
the slash. Where you are saying it's 1.
I don't know if it is my network, but you are breaking.
Can you hear me now?
Go ahead.
Like for the
Can you guys? Dominic, I can't hear. I want to confirm with the rest. Can you guys hear Dominic or it is my network?
Yeah. Dominic's network, eh?
Okay, okay. So Dominic, maybe because we are struggling to hear what you are saying. So while Dominic tries to get himself to a better place, any other question from any one of us before I say the next thing I want us maybe to finish with or something? Okay. Now, there's some practicals that we needed to do. Of course, I wanted even to use what we have here for that to do some configurations here. But before we can do that, what I can say is that I want to show us, but Dominic, if you get to a better place, you can always let me know and then you can ask the question. Okay, I'll stop sharing. Okay, I think I was sharing my entire screen and I'll come back here and try and now do something here. What is called super. Is that a word supernetting? Is double T here. Supernetting. What is called network aggregation, or what we call route summarization. So those three. Now, this is the actually the opposite of subnetting, and I just want to use an example here. The example that I want to use is something that looks maybe like this. I can write out many networks here. For example, let me start with a simple one. Let me just a simple one. Let's say we have 10.0.0.4/24, or we have 10.0.0.5/24, or okay, what's that? Or we have 10.0.0.6/24. So these are three networks. So we want to summarize. Now, route summarization, or what we're calling supernetting, is to make sure that the router will not have so many entries in its routing table. So we want to minimize the number of entries into a router's routing table. So then what you do what is called route aggregation or route summarization, or what is also called supernetting. Supernetting. So to summarize these routes into just one route that will take care of all of them. I hope you guys can hear me, because where I am, it is raining, and it is not raining cats and it is raining elephants and giraffes. But I hope you can hear me. At any point, if you lose me, just let me know. So now, supernetting is combining several routes into one route. And because we now understand what is this? We now understand number system, and we understand binary. We want to write out all those the three routes into just one into binary. So that should be, if we do this in binary, I will not focus on the first three. I think these ones will remain the same. As you can see, they are all the same, so they won't change. So I will not focus on them. So allow me not to focus on the first three octets. Those ones will just remain the same. So we're not going to focus on them as well. So let's write out the fourth octet. Let's write out the fourth octet in binary. So for the first one, it is going to be 1, 2, 3, 4. That is 8. That is 4. That is 2. That is 1. Then the second one, 1, 2, 3, 4. That is 8. That is 4. That is 2. That is 1. Then the last one is 1, 2, 3, 4. That is again 8. That is 4. I mean, where is saying 8? That is 8. That is 4. That is 2. That is 1. So if you write them in the last octet of those 4 addresses in binary, this is how they look like. Now again here, we will look, all this is the same, as you can see, across all of them. So now what is the same, we leave it as is. And then everything else, we convert them to all zeros. Everything else, we convert them to all zeros. So now if we were to write all of them, if we were to convert all of them now to all zeros, it means that starting from here, I'll just tab it, tutakuwa na 1, 2, 3, 4, 5. I mean, oh, no, why am I doing that? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 1, 0, 0. The second one, the same. The second one, 1, 2, 3, 4, 5, 1, 0, 0. Then the third one will also be the same. 1, 2, 3, 4, 5, 1, 0, 0. So we are summarizing these routes. Then now with that, we then compare this one with the what? The subnet of the subnet of the what am I saying? You just come here and say you put down the last octet there. The last octet is going to be we know the last octet is all zeros. So 1, 2, 3, 4, 5, 6, 7, 8. So with the last octet as well, we just continue with that law that what is the same remains the same even here. So it just comes down like that. Then what you do, you convert these ones to all ones. This side, let me get this. You convert now these ones that are here to all ones and these ones to all zeros. Hiyo ni kwa subnet sasa. You convert these ones to all ones. What we have this side to all zeros. So again, if you convert now the subnet and follow that rule, that we are saying that subnet is now supposed to be like this. It's going to be 1, 2, 3, 4, 5, 6, 0, 0. So if you were to summarize this, how many routes are this? These 3 routes into just one route that takes care of all of them, then this is, okay, what did I do there? Then this is what you will have. Let me now clear this. I hope up to that point we are together. This is what you will have. What you will have will be now, you just write this one out in what? In, if you write this one in binary, in decimal, it will give us, that is 1, 2, 4. So this one is going to be 4. 4. This is a 4. And all of them are 4. And the subnet here, this one is 255 minus 3. If you don't understand any of 252, so the single network for all those networks will be 10, because one remains .0.0.4. But now this one becomes slash what? Not slash 24. It becomes slash 24, 25, 26, 27, 28, 29, 30, slash 30. So this is the summarized route for all these routes here.
Excuse me.
Yes, Dominic, now I think you are clear.
Where did you get the 3 that you are subtracting from 255?
Very good. If we convert these ones to all ones, it will give us 255. Is that true?
Sure.
But then we have these 2 are zeros, so we can't add them because they are zeros. So this one is a 1. We know that this one is a 1. This one is a 2. Is that true?
Yeah. Come again.
If this one is 1, Sindio, this one. That one is 1. This one is 2.
Yes.
That one is 2.
Yes.
We know this one is 4. The next one is 8. The next one is 16, 32, 64, 128. Is that true?
Yeah, that's true.
Now, these two, from there, these two are not, they are not ones, they are zeros. So what I didn't want to do, okay, the other thing I can do, Dominic, I should have done this. I should have said 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus, yeah, up to that. Do you know where these ones are coming from?
Yes. When we raise 2 to power 7, 2 to power 6, back to 2 to power 0.
Exactly. But you see now I can't add for these two because they're not ones. Is that true?
Yes.
So instead of adding this way, I just took a shortcut and said, I know that if they were all ones, if these are all ones, it will give me 255. But because I know this one is a 2 and this one is a 1, that is a total of 3. So I just say 255 minus 3. That 3 ni hizi mbili hapa. Because this one is a 1.
Thank you very much. That's clear.
Okay. Any other person mwenye amekwama ama anataka kuexplainiwa further? So if we were to...
Still me, sorry for taking you back.
Okay, yes.
When my network was not clear,
Yes.
I wanted to seek clarification on there's a part that I was getting lost after determining the number of bits that would be required. For example, to accommodate 8, we found it's 2 raised to power 4. Now,
Yes.
the next step where we are now converting to binary was not very clear for me, especially the last bit.
Okay, so we said that we have 8. We need 8. We have 8 users. And the broadcast address of which was that of Eldoret or Nakuru was 172.16.100.223, if I'm not wrong. That was the broadcast address for /27. That was the broadcast address for Nakuru. I don't know if you had seen that. Now we ask, okay. Now we ask ourselves, how many host bits do we need in order to, first of all, what is the network address now? Remember now network address for Eldoret will be, you take the broadcast address and add 1, which is 172.168.100.224/27. Up to this point, we will retain /27, but we ask, is it the correct slash there? We're just about to find out about that. So we ask ourselves how many, because if you write /27 in binary, just /27/27. If you write it in binary, it is equals to 24, 25, 26, 27. 1, 2, 3, 4, 5. This is /27 in binary. And /27, when it is in binary like this, it means that these ones are the host bits, those 5 bits. So we ask ourselves, how many host bits do we need in order to make sure we take care of 8 users? And we said it is 2 raised to power 4 minus 2, which will give us 14. Now, if we only need 4 host bits in order to take care of 8 users, we say then this 5 host bits is way too much. We can't use /27. So we say we now say that the next thing to do is to change that one from 1, 2, 3, 1, 2, 3, 4, 5 but then we also make this one to be a network bit so that we have only 4 bits as the host bits. And so that with that, we first of all change this now to /28 and say now that we have our network, we needed to find out the broadcast address. But I don't know if up to that point your question is answered, or I should continue further.
Yes, where you replaced 0 with 1. Maybe you've said at that point you are making it also a network bit.
Yes, so when we see here, we have 5 host bits, but 5 host bits, that one will give us 32 addresses, which is way more than 8. We will still waste more addresses. So we want to make sure that we do what is called efficient use of IP addresses. We don't waste addresses. Or if we must waste, we waste very minimal. Here, if we use 5 host bits, that one will make sure we are wasting 22 addresses. So we ask, is there a way to reduce that wastage? The answer is yes. What do we do then? We will convert one more host bit to a network bit. And so here, that is what we have done. We've said this bit now has become a network bit, and we are only left with 4 host bits. Now, with 4 host bits, we will end up wasting just 6 addresses, but it's way better wasting 6 than wasting 22 addresses, because this 14 will still take care of our 8 users here. Does it make sense?
Yes, you're clear now.
Okay. So up to that point, any question?
If you end up wasting the addresses, it means it will cost you on the next subnetting. I mean, if you are to continue subnetting.
Exactly. It will end up, because this is the thing. Look at this. Let's just focus on this example. We had Nairobi. We have Kisumu. I think Nakuru. And then Eldoret. And if we don't subnet, let's assume we say we are not subnetting. It means that all those addresses, remember they are 254. I hope you know where 254 comes from, because our address was 172.16.100.0/24, which gives us, it means this network has 254 addresses. If we say we will not subnet, then it means that Nairobi will use the entire 254 addresses, and because they only need 110, they only have 110 users, we will end up wasting 144 addresses, and we will have 0 addresses for Kisumu, 0 addresses for Nakuru, 0 addresses for Eldoret. So these guys won't be able to connect to that network. So you must make sure, if you must waste the minimum number of host addresses as possible, but then make sure you subnet to meet your requirement. So this is a scenario where if you don't do the subnetting, you will take care of these guys, but you can't take care of the guys. Or if you say, no, I'll just borrow 1 bit per yake and that's all, you will only take care of Nairobi and Kisumu. If you just borrow 1 bit and say, I'm going to use a /25, that will give you 2 network bits. You will borrow 1 host bit, make it a network bit, will give you 2 subnets, and that maybe will then take care of Kisumu and Nairobi, and that's all. We want you to take care of Nakuru and Eldoret branches. Okay. Does that answer your question, Bevin?
Sure, it does. Thank you.
Okay. Any other question? I thought we'll be able to do some practical, but the time is far much spent. So maybe, there's a lot, so maybe we can dedicate our next meeting for some practical, now to see this subnetting in action, how we can use it in a lab environment to see how it works. And before we then resume with our topics, because we have several topics. We have covered now, that is topic IP, addressing and subnetting, and number system. We still have several to go. We haven't covered IPv6. But you see, we are struggling to subnet in IPv4. IPv6 is the easiest. I mean, ni kama tu walkover to subnet in IPv6. Very, very straightforward. So, that is IPv4 that we've talked about. We'll talk about IPv6. See the type of networks, see how subnetting there is easy, very easy, and things like that. So, unless any of us has something and can clarify, I think we can call it a day. And then if God continues to be gracious to us, then we can meet in our next class, in our next session.
Thank you, Mr. Apollo. We continue to appreciate. Would it be possible to share this your worksheet on the WhatsApp group so that we're able to download it?
This one?
The one that is visible on the screen.
The one
Yes.
is okay. Yeah, okay. Maybe next time I'll also try to make sure I am a bit more organized and try to explain this. Because you see, hii tu ni ya jana. Today's one nilifanya huko kwa packet tracer using this annotation tool. You see, the issue with annotation tool is that once you exit, that content also disappears. But then maybe next time I'll try to just make sure I use something like this. But this one I can share.
Okay. Okay.
All right.
Thank you.
Okay. So asanteni sana. Let's do this again next time.
Yes, Austin, before you go.
Yes.
Thank you for the effort you're putting. And I was asking, which platform can we get now the recordings?
Now this recording, this one is recorded locally, so I'll be able to share this. This one I can share. I think it is in my computer. I hope I'll get it, and I just hope it is recording. I hope it is recording. So if it is recording, it is recording. So I'll share this. I'll share this recording ya leo.
Okay, thank you so much.
Okay. So meanwhile, guys, I think this week I'll share with on that WhatsApp group. I'll share some assignments relating to subnetting. In fact, I have one that I want to share as soon as even maybe after this. I want you guys to attempt it, and you share. It is on subnetting. Actually, it is borrowed from CCNA. There's a CASNEB called CASNEB as something they are calling CCNA, which is what is this? Certified Information Systems Solutions Expert. They have borrowed one of their paper directly from CCNA, directly. In fact, I'm going to share with you some of those questions here on that platform. I want you guys to attempt them. Again, also, let me see if I'm able to log into this at this point. I want you guys also to attempt this nini. I want to attempt, let me just log in and see what we have here, because there's enough material for your practice. Let's see here. Once you get in here, okay. Now, why am I okay? I don't even know why I'm struggling to find what I want here. If you go to Introduction to Networks, because you guys are able to access to see this, and then that was specifically, you see, this one here. After the first four topics, there will be this exam here that I will want you guys to attempt. So it is currently locked. Once we have covered, so far we have covered this and this and this. So you should be in a position to attempt this exam. I'll just make sure in the course of the week it is activated for your attempt and see how you fare on. It's just to then what we've covered is actually we did cover number system, which is this topic 5 here yesterday. So for example, if we were to focus on just that, if you click on this topic, from your end, when you are reading through this, you can always scroll all those materials, the slides that I use is actually just borrowed from here. So it has all that, but if you come down here, there's always the module quiz. You can always test yourself and see. So module quiz, number system, and you come here and say module quiz number system and you start and see those quizzes. For example, what is the binary representation of decimal number 173? Just look for it and see how you will score. So for me here, I don't know what 173, 120, it should start with a 1, of course. Of course, you can do that. I'm not going to do it right now, but then you go to the next question, question 2. Let me get this one out of the way, kidog. Then that is question 1. Where's question 2? Okay. Skip that. Let me skip that and go to next question. Given the binary address, this one here, which address does this represent in dotted decimal? You should tell us what that one is here. But ukiangalia hii hapa ni 1010, that is a 10. So it should end with a 10. So this one is out. This one is out. Should be either this or this. Which one can we pick? This one is 1100. This one is a 4 plus 8. That is 12. So I think this should be the answer. That should be the correct answer. But of course, you guys try that. I can skip that question and go to the next. How many binary bits exist within IPv6? IPv6 is 128. I think we have not talked about IPv6. But I mentioned, I don't know if I mentioned, it should be 128, then you can skip and see. So you can try that. Ukienda pia kwa topic number 11. Let me get this out of the way again. If you go back to topic number 11, you can go and try some of those things that we've been looking at. Just these things you learn by practicing IPv4. We've covered this. And once you get to IPv4, again, you can read, if you need to read, IPv4 subnetting is all there, VLSM and those things. But then module quiz is here. So if you come to module quiz, again, you can start and see what is the prefix length. Prefix length is what we're calling the slash notation. So when you see prefix length, it's just the slash notation. Is it slash 24? Is it slash 26 of this one? So this is 2 to 4. This is 24, 25, 26, 27. I think it should be this one. But again, you can attempt those questions and see. It will help you also learn these things. And how many bits, how many valid host addresses are available on IPv4 subnet that is configured with a /26 mask? I think you should be able to answer that. What is the subnet mask will you use if 5 host bits are available? To be able to answer that. If 5 host bits are available, network admin subnets this. So those are things that you guys can also do. And again, yeah, so we'll build it from there. So let me stop there for now. Asanteni sana. Na
Yes, sir.
yes, sir, Dominic?
Yes. Do we have a link to these notes and the quiz?
Yeah, there's a link that I shared on the WhatsApp group that is pinned. If you go to the WhatsApp group, you should be able to see it. It should be there. There should be a link to somewhere here. Where is that? I think there's this pinned link here. You just click on this. It will take you. You will sign up to CCNA and be able to get all of them there. Okay. So unless any other person has something that they want to ask.
All right.
Asanteni sana. And you guys have a good week.
Enjoy yours too. Thank you.